Hello, I'm Miss Igo. Welcome to my classroom. In this video, we're going to be talking about simplifying radicals. Before we get started, let's talk about some definitions. Numbers that are considered to be perfect squares are numbers that you can achieve by multiplying another number times itself. For example, 4 is a perfect square because we can multiply 2 times itself, or 2 squared, to get that number. Another perfect square would be 25, because we can get 25 by multiplying 5 times itself, or 5 squared. In math, any operation that we can perform needs to be able to be undone. Well, if we square a number, like we squared 2 to get 4, we have to be able to undo that. And to undo squaring a number, we would square root that number. When we take the square root of a number, we use this symbol, and that symbol is also called the radical symbol. The number underneath the radical symbol is called the radicand. When we have a number under the radical symbol, or a radicand, and we want to simplify this, we ask ourselves, what number can we multiply times itself to get that number? So in this case, the square root of 4 would be 2, because 2 is the number that we could multiply times itself to get 4. As we said before, 25 is a perfect square, so if we want to go in the opposite direction and we want to take the square root of 25, the number that we could multiply times itself to get 25 would be 5. So the square root of 25 is 5. The square root of 64 would be 8. When dealing with variables, any variable with an even exponent is considered to be a perfect square. To take the square root of a variable, we ask ourselves the same thing. What can we multiply times itself to get, in this case, x squared? Well, x times x would give us x squared. Therefore, the square root of x squared is x. If we were dealing with another variable with an even exponent, say x to the 4th, the square root of x to the 4th would be x squared, because x squared times x squared is x to the 4th. What happens when the number that we're trying to take the square root of isn't a perfect square? In this case, we have the square root of 20, and 20 is not a perfect square. So what we need to do is find the biggest perfect square factor of that number. If I list out my perfect squares would be 1, 4, 9, 16, 25, 36. Let's stop there for now. Now take half of the number that you're trying to find the perfect square of. So if we're trying to find the the biggest perfect square factor of 20, half of 20 would be 10. So let's look at our perfect squares. 10 would fall right here. So any perfect square factors would have to be smaller than that. So let's start with 9. Can 9 divide into 20 evenly? No, it can't. What about 4? Yes, 4 can divide into 20 evenly. So that's going to be our biggest perfect square factor of 20. 4 times 5 is the same thing as 20. So now the perfect square has to come out of the radical. The square root of 4 is 2. So 2 is going to come on the outside of the radical, and 5 stays under. And this would be our simplified radical. Let's try another one. Here we need to find the square root of 45. Again, 45 is not a perfect square. I'm going to list out several perfect squares first. Okay, so like I said before, we're going to take half of the number. Half of 45 would be 22 and a half, so that would fall right here. So again, any factors of 45 would have to be smaller than that. So when we're looking for the perfect square factors, we'll start with 16. Will 16 divide into 45 evenly? No, it won't. What about 9? Yes, 9 is a factor of 45. So 9 times 5 is 45. Once again, the perfect square factor gets to come out of the radical. The square root of 9 is 3, so now it comes out of the radical, but the 5 has to stay under. And this is my simplified radical. Let's simplify the square root of 48. 48 is not a perfect square, so again, we're just going to have to simplify it by taking out any perfect square factors. So we'll start with half of 48. Half of 48 would be 24, so that would fall right here. So we have to look at the number smaller than half of 48. So we start with 16. Will 16 divide into 48 evenly? Yes, it will. 16 times 3 is 48. The perfect square, 16, gets to come out of the radical as 4 because the square root of 16 is 4. And the 3 stays under. So 4 square root 3 is my simplified radical. In this last example, we have something a little different. We have a number that's connected to the radical by multiplication. So this is 4 square root 27. 27 is not a perfect square, so we need to simplify that. And anytime we have a number that's connected to a radical by multiplication, whatever comes out of the radical gets multiplied times that number. So let's simplify our 27. Half of 27 would be 13 and a half. So that would fall between 9 and 16. So again, we go smaller. 9 is the first perfect square that's smaller, and 9 will divide into 27 evenly. So 27 is the same thing as 9 times 3. Okay, so our 4 is just going to tag along, and then the 9 comes out of the radical as a 3. And like I said, whatever comes out of the radical gets multiplied times the number that's already outside the radical. And then this 3 stays under the radical. So now we have 4 times 3, which is 12 square root 3. And we have simplified our radical. And that's how you simplify radicals. Thanks for watching.